So let's draw our axis first. So on x-axis I have volume in liters, and on y-axis I have pressure in atmospheres. And the range of x-axis is 1 liter to 2.5 liter, and range on the y-axis, which is pressure, is zero point 0.4 and 1.0. Now there is a segment which is when we have compression at constant pressure. So since the process is at a constant pressure, this path should be horizontal from 2.5 to 1 liter, and that compression occurs at a pressure of 1 atmosphere. So we should have a straight line going from 2.5 liters to 1 liter, and the direction should be like this because it's going from because it's a process of compression, so we must have a decrease in volume, and the process is occurring at 1 atmospheric pressure, hence the horizontal line should be positioned at that place. Let's call this a segment A. Then we have isothermal expansion. And in isothermal expansion, we know that the pressure is constant. And the ideal gas law says that since PV is equal to nRT, where n times R is a constant, therefore, when temperature becomes constant, like the isothermal case, we have PV to be constant. So, for the process of isothermal expansion, we must have volume uh, decreasing if pressure is increasing, because now pressure becomes inversely proportional to volume. So our uh, path for this particular process for the isothermal expansion should follow this condition. Since volume is increased by a factor of 2.5 here in this process, the pressure must decrease by a factor of 2.5. The pressure must be divided by 2.5. So the final segment on this, the final point, so let's draw the segment simply. So the path should somehow look like this, since we have pressure inversely proportional to volume, and the final point on this segment is at a pressure of, so we started at 1, and since volume goes from 1 to 2.5, which means that volume gets multiplied by a factor of 2.5, therefore pressure must decrease by a factor of 2.5, or pressure must get divided by a factor of 2.5, because these two are inversely proportionals. And we started at a pressure of 1 atmosphere over here. This means that the final point in this process will be the initial pressure 1 atmosphere divided by 2.5, and this is equal to zero point 0.4 atmosphere. So hence we have zero point 0.5 zero point 0.4 atmosphere as the final point. Let me just oops. Okay, so let's go back. Oops. Okay, there we go. So the final point would be aligned with zero point 0.4 atmosphere. And since the process is going from here to here, therefore the direction should be like this. And let's call this the segment B. Now then the final step is pressure increase at constant volume. And since the process before ended at a volume of 2.5 liters. Therefore, the pressure should start increasing at this volume. And since volume is constant, therefore, this is just going to be a vertical line with constant volume and increase in pressure. And hence the path on the diagram is from zero point 0.4 atmosphere to 1 atmosphere, and let's call this segment C. So that's the phase diagram, the PV diagram for the problem.